Well, today we will discuss one topic of this vector calculus, and that one is what is velocity and acceleration, and how can we define tangential and normal acceleration and relative velocity and relative acceleration. So, let us define first what is velocity in vector calculus. So, let us suppose this one is x axis, y axis, z axis, and this one is a curve, and this P point, initial point P naught at T naught, and this point is P at T, and position vector of this P is R, okay, and this point Q is neighboring point, and at T is equal to T plus delta T. So, position vector of this one is R T plus delta T, and delta S is this length, this arc length, and this one is S, arc length S, okay, and P Q is delta R, right, and X be any point on this tangent, okay. So, let the position vector of a particle P, position vector, position of a particle P at time T, T is scalar variable on a path C be RT, this one, okay. At time T plus delta T, let the particle be at Q, okay, at time T plus delta T. So, at time T plus delta T, clear, let the particle at position this Q. Then delta R is equal to, in that case when we have given position vector of this point, then how can we write delta R? So, delta R is RT plus delta T minus RT, clear, delta R is RT plus delta T minus RT. Now, delta R over delta T is directed along this chord PQ, okay. So, delta R over delta T. So, delta R over delta T, the direction of this is directed along this PQ, okay. Now, as Q approaches towards P, as this point approaches towards this point P along this curve C, this one is a curve C, okay, along curve C, the line PQ becomes, देखिए जैसे ही ये पॉइंट इस तरह मूव करेगा, ठीक है, तो जब ये पॉइंट यहाँ पर पहुंच जाएगा तो ये जो पी क्यू है इसकी डायरेक्शन ये हो जाएगी, क्लियर. सो द लाइन पी क्यू बिकम्स द टेंजेंट एट पी टू द कर्व एट सी, क्लियर. सो therefore limit delta t tend to 0, delta t means as Q approaches towards P. So, when as Q approaches towards P, then this means delta t tend to 0, clear. So, limit delta t tend to 0, delta R over delta t is equal to, the limiting value of this ratio is dr over dt, and dr over dt is nothing but v is velocity, clear. So, this limiting value of this ratio means dr over dt is the tangent vector, of C at P, okay. So, dr over dt is the tangent vector of C at P, which is the velocity vector v of the motion, and its magnitude is the speed v is equal to ds over dt. So, this means that the magnitude of dr over dt is nothing but this v is ds over dt. So, where s is the arc length, okay, of P from a fixed point P naught, which is at position t is equal to T naught, clear. Now, on the same line we can define the acceleration, clear. So, how can we define acceleration? So, velocity is clear. So, as Q approaches towards P, right, this PQ becomes the tangent at P, okay, to the curve C. So, this limiting value is dr over dt, which is nothing but tangent vector of C, clear. So, the derivative of velocity vector is called acceleration vector A, clear. The derivative of the velocity vector is called the acceleration vector A, which is given by, so A is equal to limit delta t tend to 0, delta v over delta t. This means the limiting value of this ratio is nothing but dv over dt, and we know dr over dt. So, it becomes d square r over dt square, okay. So, that one is the acceleration, okay. So, next topic is how can we define tangential and normal acceleration, clear, tangential and normal acceleration. So, it is important to note that magnitude of acceleration, clear, is not always the rate of change of magnitude of v, because A, which is known as acceleration, is not always tangential to the path c. Clear? So, in fact, how can we define v? V is dr over dt, but dr over dt can be written as dr over ds, ds over dt, where dr over ds is unit tangent vector to the curve at c. Clear? Then calculate A. A is dv over dt, dv over dt means d over dt, ds over dt dot dr over ds. So, the value of v is this dr over ds, ds over dt. So, the value of this one is clear, ds over dt dot dr over ds. Now, it becomes d square s over dt square dot dr over ds plus ds over dt square d square r over ds square. Okay. Now, see, dr over dt dot d square r over dt square is equal to 0. Clear? एक बार आप इसको डिफरेंशिएट करोगे विद रिस्पेक्ट टू t, then dot product of these two vectors is equal to 0. Clear? So, this means d square r over dt square is perpendicular to dr over dt. D square r over dt square is perpendicular to dr over dt. Okay? So, hence acceleration A is comprised of number 1 this factor, number 1 this factor, and number 2 this factor. Okay? And this factor is known as tangential acceleration. This component is known as tangential acceleration. Clear? And this component is known as normal acceleration. Normal acceleration. Clear? So, this one is tangential acceleration. We know dr over ds. Dr over ds is basically perpendicular to this r. Okay? So, dr over ds, that one is tangential acceleration, and d square r over ds square is normal acceleration, because d square r over dt square is perpendicular to this dr over dt. So, that one is normal acceleration, normal component of acceleration. So, remember, we know acceleration is this, and this component is tangential component of acceleration, and this component is normal component of this acceleration. Okay? So, the direction of this one is tangential, tangent, okay, and the direction of this one is perpendicular to tangent. Clear? So, this one is tangential acceleration, and next one is normal acceleration. Clear? So, the acceleration is the time rate change of magnitude of v, which is equal to ds over dt, if and only if the normal acceleration is 0. Clear? If the normal acceleration is 0, then we say that if normal acceleration, if this part is 0, then we can say that this this time rate change of magnitude of v, okay, is equal to ds over dt. Okay? In that case, we can calculate magnitude of A is d square s over dt dt square. Okay? So, when we take magnitude, okay, so magnitude we get this magnitude of this, and dr over ds is nothing but this is the value of this one is 1. Okay? So, magnitude of A is equal to d square s over dt square. So, that one is tangential and normal acceleration. तो जब भी इस टाइप की प्रॉब्लम आ जाए, ठीक है, तो आपसे पूछा जा सकता है कि राइट द टेंजेंशियल एक्सेलरेशन एज वेल एज नॉर्मल एक्सेलरेशन फॉर दिस प्रॉब्लम. ओके, सो नेक्स्ट वन इज हाउ कैन वी डिफाइन इन वेक्टर कैलकुलस द रिलेटिव वेलोसिटी एंड रिलेटिव एक्सेलरेशन, राइट? So, let us suppose we have two curves C1 and C2, okay, C1 and C2, and we have two particles P1 and P2 moving along the curve C1 and C2. Okay? तो ये जो पार्टिकल है ये इस कर्व पे मूव कर रहा है और ये पार्टिकल इस कर्व पे मूव कर रहा है. ओके, सो लेट टू पार्टिकल्स P1 and P2 moving along the curves C1 and C2 have position vectors R1 T, R2 T, okay, at time t. Okay, so have position vectors R1 and R2 at the time t respectively. Okay, so this one is origin. Okay, so this position is R1, that one is R2. And then what is the value of R? R is P1 P2, okay, P1 P2, which means R2 minus R1. Okay, so this means R is equal to R2 minus R1. Clear? So this R is nothing but R2 minus R1. Okay, so this vector. Okay, so differentiating with respect to t. Okay, so differentiate this term with respect to t. So we obtain dr over dt is equal to dr2 over dt minus dr1 over dt. What is this? This defines the relative velocity of P2. Okay, relative velocity of P2 with respect to P1. Relative velocity of P2 with respect to P1, and states that the velocity vector of P2 relative to P1 is equal to. Okay, so this dr over dt is velocity vector of P2 relative to P1 is equal to, this one is velocity of P2 minus this one is velocity of P1. Okay. So, in this way you can define this relative velocity, okay, relative velocity of one particle P2 with respect to P1. Okay. So, this one is dr over dt, dr over dt is relative velocity of this point, okay, with respect to P1, clear. So, that one is the mathematical expression for evaluating the relative velocity. Similarly, again differentiating. So, once again when you differentiate, you will get d square r over dt square is equal to d square r2 over dt square minus d square r1 over dt square. This means that is acceleration of P2 relative to P1. This one is acceleration of P2 relative to P1 is equal to acceleration of P2 minus acceleration of P1, clear. So, in this way you can define the relative acceleration also, okay. And one here very important remark is component of A, component of acceleration along the tangent, और tangent की direction में क्या होता है, v होता है, ठीक है. अगर velocity v दे रखा हुआ है तो उसका unit vector क्या होगा, ठीक है ना, v divided by magnitude of v, clear. So, component of A along the tangent is A dot v cap is unit vector towards the velocity vector, right, and that one is v divided by magnitude of v, okay. And second one is, what is the component of A along the normal? So, that one is along the tangent. What is the component of A along the normal? That one is magnitude of A minus resolved part of A along the tangent. What is this? A minus resolved part of A along the tangent. Along the tangent means V over magnitude of V. Okay. What is the resolved part of A? That one is A dot V cap. That one is the resolved part of A. But along the tangent means V over magnitude of V. So, about the tangents, so velocity is the V cap is the unit vector. So, V over magnitude of V. So, remember these two formula for evaluating the component of A along the tangent as well as along the normal. Okay. Then let us discuss now few problems. This all about this velocity, acceleration, relative velocity, relative acceleration. So, let us discuss few problems today. Okay. So, find the radial and transverse acceleration. This means we are going to calculate the radial component of acceleration, transverse component of acceleration, okay, of a particle moving in a plane curve. Of a particle moving in a plane curve. So, let us suppose that this x axis, this y axis and this one is a point P, and the position vector of P is r theta. R means from this point to this point distance is r, okay, and theta means this angle, this line makes with x axis this angle theta, okay. So, this means capital R is equal to r cap. So, when you take magnitude, so magnitude r is equal to simple r cap is the unit vector. So, in this direction r cap is the unit vector, clear, and toward this direction v cap is the unit vector velocity, toward this direction v cap is the unit vector. तो ये figure बिल्कुल clear है. So, P is a point which moves along this curve, okay. At this point position vector is P r theta means this distance is r and theta makes an angle with x axis and this one is v cap, okay. So, at any point t, let the position vector of the moving particle P r theta be r, okay. So, let the position vector is this, let the position vector is r, okay, of this moving particle P whose position vectors are r and theta, right. So, that one is the position vector of this moving particle, okay. Now, then what is r? R is obviously r cap, right, and r cap can be written as r cap is nothing but cos theta I cap plus sin theta j cap. R cap is, in this case r cap is cos theta I cap plus sin theta j cap and r common. So, capital this r is equal to r cos theta I cap plus sin theta j cap. Now, calculate velocity. Velocity is dr over dt. dr over dt means d over dt r cap. So, r cap, okay, and it becomes dr over dt r cap plus r dr cap over dt, clear. So, we have these two parts of velocity. So, v is equal to this result. Now, since r cap is equal to cos theta I cap plus sin theta j cap, then what is dr cap over dt? So, dr cap over dt is equal to minus sin theta I cap plus cos theta j cap and d theta over dt. क्लियर। और आप अगर आप इसका मैग्नीट्यूड ले लो तो मैग्नीट्यूड बनेगा, ये तो स्क्वायर में बन जाएगा 1 हो जाएगा, तो ये बनेगा डी थीटा ओवर डी टी। सो मैग्नीट्यूड ऑफ डी आर कैप ओवर डी टी इज इक्वल टू डी थीटा ओवर डी टी. So this means that dr cap over dt is this into d theta over dt, clear, and magnitude of this one is d theta over dt. Now substitute all these values. Now we know dr cap over dt dot r cap is 0, obviously r cap is the unit vector, right, r cap is the unit vector, and if you differentiate with respect to t, then take dot product dr cap over dt dot dr cap, we get 0. This means dr cap over dt is perpendicular to r cap. ओके, आर कैप ये है तो डी आर कैप आपका इसके परपेंडिकुलर में है. सपोज करो इस डायरेक्शन में है, परपेंडिकुलर है, दिस परपेंडिकुलर है, और इस डायरेक्शन में लेट अस सपोज यू कैप इज द यूनिट वेक्टर, क्लियर. सो लेट यू कैप इज द यूनिट वेक्टर परपेंडिकुलर टू आर, देन दिस मींस डी आर कैप ओवर डी टी इज डी थीटा ओवर डी टी यू कैप. dr cap over dt is equal to d theta over dt u cap. Okay, now we know this result, okay. Substitute the value of this dr cap over dt, okay. We get substitute, when you substitute you will get d theta over dt u cap. So the r cap, the component of r cap is dr over dt, the component of u cap is this d theta over r d theta over dt, okay. So when you substitute, then one becomes velocity v is equal to this, clear. This means the radial, this one is the radial component and this one is the transverse component of the velocity, clear. Radial component and transverse component of the velocity are dr over dt and r d theta over dt respectively, okay. So in this way you can evaluate the radial and transverse component of velocity, but purpose is to evaluate the radial and transverse component of acceleration, clear. So again differentiate with respect to t. So a is equal to dv over dt. So when you calculate dv over dt, v is 2 terms, okay. So when you differentiate with respect to t, you will get 2 terms, and when you differentiate with respect to t 1 2 3, so you will get 3 terms, okay. अब आपने क्या करना है, रेडियल कंपोनेंट निकालना है और ट्रांसवर्स कंपोनेंट निकालना है. तो रेडियल कंपोनेंट कैसे निकालोगे, कोलेक्ट द कोएफिशिएंट ऑफ आर कैप, और ट्रांसवर्स कंपोनेंट कैसे निकालोगे, कोलेक्ट द कोएफिशिएंट ऑफ यू कैप, क्लियर. सो हियर आर कैप कोएफिशिएंट इज दिस एंड यू कैप कोएफिशिएंट इज दिस, ओके. ऑन द सेम लाइन कैलकुलेट हियर. अब देखिए, एक तो आर कैप का कोएफिशिएंट ये आ गया, ये मैंने यहां लिख दिया, क्लियर. अब यू कैप का एक यू कैप एक टर्म जो है यू कैप की ये आ गई, ओके. ये टर्म यहां पे आ गई, 2 टर्म्स क्लियर होगी. और यू कैप आपका ये भी है dr ओवर डी थीटा डी टी, ओके. dr ओवर डी टी डी थीटा ओवर डी टी. तो एक टर्म आपकी ये आ गई, अभी 2 बचा, एक बचा हुआ है, ठीक है. अब आप ये रिजल्ट देखिएगा, ये रिजल्ट क्या है, ठीक है ना. आपको ये देखना है और आपको ये देखना है, क्लियर. अब देखिए dr ओवर डी टी, dr ओवर डी टी, dr कैप ओवर डी टी, ओके. सो dr कैप ओवर डी टी, देखिए ये रिजल्ट, dr cap over dt is d theta over dt u cap. So it becomes d theta over dt u cap. So dr over dt and d theta over dt, तो ये टर्म यहाँ पे इंक्लूड होकर 2 टाइम्स बन गया, ठीक है. और उसके बाद आपने ये देखना है du cap over dt की क्या वैल्यू है, du cap over dt की. देखिए u cap, what is u cap? U cap is minus sin theta I cap plus cos theta j cap. This means du cap over dt is minus d theta over dt r cap. So in terms of r cap you can write, so you will get this value, r d theta over dt square, and here r cap, and sign is negative, minus d theta over dt r cap. So collect the coefficient of r cap and u cap, you will get this one is the radial component of acceleration and this one is the transverse component of acceleration, okay. So thus the radial component of acceleration is this and transverse component of acceleration is this, and this completes the proof of this problem, okay, solution of this problem, okay. So in this way you can calculate this radial and transverse component of velocity as well as acceleration, okay. Now one problem related with the velocity and acceleration, how can we determine velocity and acceleration, okay, vectors. So a particle moves along the curve, x is equal to e raised power t, y is equal to 2 cos 3t, z is equal to 2 sin 3t, where t is the time variable, clear. What is the vector equation for this curve, for this problem, okay, for this curve? Vector equation is r is equal to xi cap plus yj cap plus zk cap. Obviously r is equal to xi cap plus yj cap plus zk cap. So what is r? R is e raised to power minus t I cap plus 2 cos 3t j cap plus 2 sin 3t k cap. That one is the vector equation of this curve. Okay. Determine its velocity and acceleration vectors and also magnitude of velocity and acceleration at t is equal to 0. Okay. So, first write on the vector equation of the curve. So, in this problem vector equation of the curve is this, as we have discussed now. Okay. R t is equal to e raised power minus t I cap plus 2 cos 3 t j cap plus 3 sin t 3 t k cap. Okay. Then calculate velocity vector v. V is d r over dt. So, calculate this one. Okay, d over dt. So, when you calculate you will get this one. Okay. So, that one is the velocity vector. Determine the velocity vector. So, this one is the velocity vector, minus 3 minus e power minus t I cap minus 6 sin 3 t j cap plus 6 cos 3 t k cap. That one is the velocity vector. Okay. What is the magnitude of this velocity vector? Okay. This square plus this square plus this square and under root. Okay. And resolve this problem. Okay. Simplify this one and you will get e raised power minus 2t plus 36 under root. But t is equal to 0. Okay. So, t is equal to 0, magnitude of v is under root 37. So, that one is the second part. So, magnitude of velocity at t is equal to 0 is under root 37. On the same line, calculate the acceleration vector. Okay. So, acceleration vector is dv over dt. So, differentiate this whole term, this term with respect to t, clear. So, you will get this one is the acceleration vector. Okay. And then calculate the magnitude of acceleration vector. So, magnitude इसका आप लीजिए, ठीक है, इसको simplify कर लीजिए, ठीक है, इसको आप simplify करके आप देखिए ये रिजल्ट आएगा. ओके. e raised power minus 2t plus 324 under root. Now, t is equal to 0. So, substitute t is equal to 0. So, acceleration vector is 325 under root. Okay. 325 under root. So, in this way you can calculate such type of few problems related with velocity and acceleration. Okay. So, first write the vector equation of the curve and then calculate the velocity and acceleration, then magnitude of velocity, magnitude of acceleration, and particular when t is equal to 0, you have to calculate all these values. Okay. So, one more question. A particle moves on the curve x is equal to 2t square, y is equal to t square minus 4t, z is equal to 3t minus 5, where t is the time. Find the component of velocity and acceleration at time t is equal to 1 in the direction of this. In the direction of this I cap minus 3 j cap plus 2 k cap. तो एक पर्टिकुलर डायरेक्शन दे रखी हुई है, उस डायरेक्शन में आपने वेलोसिटी और एक्सेलरेशन के कंपोनेंट को निकालना है. पहले क्या था, एक टाइम पर निकालना, एक टाइम t इक्वल टू 0 पर कैलकुलेट करना है, बट यहां पर एक डायरेक्शन दे रखी हुई है. ठीक है. तो कोई भी कंपोनेंट किसी भी डायरेक्शन में निकालना हो तो उस कंपोनेंट को आप उस यूनिट वेक्टर के साथ आप कर सकते हो. ठीक है. डॉट प्रोडक्ट लेके calculate कर सकते हैं. So, first write on the vector equation of the curve. So, vector equation of the curve is this. Calculate the velocity. Velocity is this, and at time t is equal to 1, we have 4 I cap minus 2 j cap plus 3 k cap. Okay. So, velocity is this. Similarly, second part is component of velocity in the direction of this. So, component of velocity at time t in the direction of this d can be calculated as v dot, v is this, dot d cap. D is this. D is this one is D, that one is D, clear. So, in the direction of D cap means in the direction of this vector, this means D over magnitude of D. ये मैं क्यों ले रहा हूँ, क्योंकि मुझे इस डायरेक्शन में वो निकालना है. ओके. इस डायरेक्शन में निकालना है. ओके. D cap डायरेक्शन में निकालना है. ओके. So, D cap is D over magnitude of D, clear. So, V dot D over magnitude of D. So, when you calculate you will get 8 over 7 under 14. So, when you calculate this simple calculation, okay, you will get 8 over 7 under 14. So, that one is component of velocity, but our purpose second part is component of acceleration. So, acceleration is dv over dt, and dv over dt at t is equal to 0, at t is equal to 0. So, at t is equal to at t is equal to 1, okay. So, we get 4 I cap plus 2 j cap plus 0 k cap. Then what is the component of A along this direction? A dot d over magnitude of d. Okay. So, simplify, you will get this result. You will get this result minus under root 14 divided by 7. Okay. So, in this way you can evaluate these type of problems. Okay. Specifically when vector equation is given and velocity and acceleration we have to evaluate at any time t or in any direction d. Okay. So, one more problem, A particle moves along the curve r is equal to t cube minus 4t I cap plus t square plus 4t j cap plus 8t square minus 3t cube k cap. So vector equation of the curve is given here. Okay. So where t denotes time. Find the magnitude of acceleration along the tangent and normal at time t is equal to 0. Along the tangent and normal. Very important. Along the tangent and normal. Clear? So vector equation is given. Velocity is this, acceleration is this. Okay. At time t, velocity is this and acceleration is this. Okay. Velocity is this at time t is equal to 2 and acceleration is this at time is equal to 2. Okay. Now question is, how can we evaluate the magnitude of acceleration along the tangent and normal. Okay. So we know acceleration, component of acceleration along the tangent is a dot v cap. V is this. Okay, a dot v over magnitude of. So v is this. So v cap you have to evaluate v divided by magnitude of v. So then you will get the component of a along the tangent. Okay, और tangent के direction में आपका ये है velocity. Now component of a along the normal is a minus result part of a along the tangent. So this means you have to evaluate this result. Okay. So when you calculate the this component of a along the normal, okay. So substitute the value of a and v, right. So we get ultimately 16. Similarly, component of a along the normal is magnitude of a minus result part of a along the normal. So finally, after simplification, you will get 2 under root 73. प्रोसेस आपको पता होना चाहिए, फार्मूले आपको पता होने चाहिए, फिर कोई इशू नहीं है. वेक्टर इक्वेशन लिखो, आप वेलोसिटी निकालो, एक्सेलरेशन निकालो, एक पर्टिकुलर टाइम पे उनकी वैल्यूज को निकाल लो एंड सब्स्टिट्यूट इन द गिवन फार्मूला, यू विल गेट द रिक्वायर्ड रिजल्ट्स. ओके. नाउ लास्ट प्रॉब्लम इज वेरी वेरी इंपॉर्टेंट. ओके. सो प्रॉब्लम रिलेटेड विद द एक्चुअल वेलोसिटी ऑब्लिक रिलेटिव वेलोसिटी. Okay, this question is interesting. A person going eastwards with a velocity of 4 km/h. Okay, a person going eastward with a velocity of 4 km/h finds that the wind appears to blow directly from the north. जब ये person जो है 4 km/h की स्पीड से मूव कर रहा है, तो इसे ऐसे महसूस हो रहा है कि जो wind है वो डायरेक्टली नॉर्थ से आ रही है. Okay, directly from the north. He doubles his speed. यानी कि 8 km/h. Okay, and the wind seems to come from the northeast. So this one is east. Okay, तो उसको ऐसा लग रहा है कि अब जो हवा है वो नॉर्थ ईस्ट से आ रही है. तो जब स्पीड उसकी 4 km/h थी तो हवा नॉर्थ से लग रहा था उसको, ठीक है, आ रही है. और जैसे उसने स्पीड डबल किया तो उस जो विंड है वो उसको ऐसे अपीयर हो रहा है कि नॉर्थ ईस्ट से आ रही है. ओके. Find the actual velocity of the wind. Very interesting. Find the actual velocity of the wind. So let us suppose that the actual velocity of the wind is this, xi cap plus yj cap. So ultimately purpose is what? Purpose is to evaluate the value of x and y. Okay. Now where I cap and j cap represent the velocities of 1 km/h towards the east and north respectively. So this means that in this direction I cap. Okay, in this direction j cap. Clear? So I cap represent the velocity of 1 km towards the east and north respectively j cap. J cap north respectively. Okay, north. So where I j represents the velocity of 1 km towards the east and north respectively. Okay. So we have ultimately two problems, two equations. Okay, when speed is 4 km/h, okay, wind appears to blow directly from the north. Okay. When speed is 8 km/h, then wind seems to come from the northeast. Question is, what is the actual velocity of the wind? So purpose is to evaluate the value of x and y. So as the person is going eastwards with a velocity of 4 km, his actual velocity is 4 I cap. Okay, इसका मतलब अगर 4 km है, I cap इस डायरेक्शन में यूनिट वेक्टर है, तो इसका मतलब उसकी जो एक्चुअल वेलोसिटी जो है वो है 4 I cap. Clear? Now then the velocity of the wind relative to the man is velocity of the wind relative to the man is xi cap plus yj cap minus 4i cap. So that one is the velocity of the wind. Okay, velocity of the wind minus 4i cap, which is parallel to ये नीचे की तरफ आ रही है, तो j cap इस डायरेक्शन में यूनिट वेक्टर, तो minus j cap. Okay, as it appears to blow from the north. So this means that this term is parallel to minus j cap. Okay. So, this term is parallel to minus j cap as it appears to blow from the north. This means, so calculate this result, x minus 4 divided by 0. So, this x and this minus 4 I cap coefficient. So, that one is 0 is equal to y minus 0 divided by minus 1. Okay. This term is parallel to minus j cap. Okay. So, result is this. Now, simplify this and finally, you will get x is equal to 4. Okay. Now, hence x is equal to 4. Now, when the velocity of the person becomes 8I, right, the velocity of the wind relative to the man is xi cap plus yj cap minus 8I, but this is parallel to minus I cap plus j cap. Again, x minus 8 divided by minus 1 is equal to y minus 0 divided by minus 1, and substitute the value of x, you will get y is equal to minus 4. Hence, the actual velocity of the wind is 4 times I minus j cap, I cap minus j cap. Okay. So, what is the speed? Speed we can calculate, that is 4 under root 3 kilometer towards the southeast. Okay. So, in this way you can calculate such type of problems. Okay. So, next we will discuss next topic in the next lecture, okay, of this vector calculus. Thank you very much.